Hello, today I will be talking about ring counter, a special type of counter that is actually very simple to understand. Let's first begin with this diagram right here. You can see this one right here. So how it works? It's basically a shift register, more precisely a right shift register. But the one major and important thing about ring counter is at any given time, you can see it also here, at any given time only one of the value of all the output will be only one. You can see here it's a 4-bit ring counter. It's a 4-bit ring counter, and if you look carefully at a given time at the four outputs right here, only the first one is 1, all are 0. Okay, this has to be maintained, and then this one shifts at the next clock pulse, and then this one shifts to the next clock pulse, and then this one shifts to the next clock pulse, and so on. So what will happen if I free run the ring counter? Say for example, at a given instant, this is logic, this is here logic 1. Then after one clock pulse, the one will be shifted towards this point, and after one clock pulse the one will be shifted towards this point. So it's something like this, and then the next clock pulse it will shift towards this point, and another, if I put another clock pulse, that is the fifth clock pulse, it will move towards again in this position, and so on. You can easily understand it will be just circulating. Okay, so this is known as a ring counter because it is forming a ring, right? Going back from t0, then again to t0, from t0 to t3, then again back to t0. So it's actually forming a ring, so that's why it is known as ring counter. So how can a ring counter be constructed? It is very simple. Say for example, for this 4-bit ring counter, what we can do, we can actually make ring counter in two different ways. One is a shift register type. So one is like this. So we take 4 D flip-flops, these are all D flip-flops, okay, and make a shift register, right shift register out of it. So just connecting the output of the one register to the input of the another one, and as this is a synchronous circuit, all the clocks should be shorted. As you know by now, synchronous circuit means that all the clocks need to be shorted. So this is your input, and this is your, okay. So now, to say, I will just make this connection to make it a ring counter. So the output of the last one is the input of the first one. So this point right here is t0, this is in fact t1, this will be t2, and this point will be t3, this one t3. So this is one way to construct a 4-bit ring counter. Another way is drawn above right here, you can see this. So you can also make it using a 2-bit counter and a 2 to 4 decoder. See that uh, you will give a clock pulse at the 2-bit counter, so the 2-bit counter will count this sequence 0 0, so it will be 0 1, then 1 0 and 1 1. So see that when it is in this state 0 0 0 0, it, the output will be 1 here, but when in the next clock pulse it will be 0 1, then the output will be 1, because it is 0 1 at this point. So this point, this will be only 1, and all the rest will be 0, right? And then when it will be when it will be 1 0, when it will be 1 0, this, so this is 1 and this is 0, then it will be 1. Okay, so and so on, you can easily understand. So we are actually using a 2-bit counter to produce these different four different states, 00 01 10 11, and using that output we are actually triggering the 2 to 4 decoder to produce our desired output like 0 1 2 3 and so on. So this is how we can make ring counter. These are the two types to make ring counter. You can this is a 4-bit ring counter, you can make more bits out of it. Okay, so if you have any question, please leave a comment. Thank you guys.